So hello everyone and welcome to AIARD's second Fireside Chat series. And this time we're going to be talking a little bit about soil health and international development with Dr. Job Kihara, who is from the International Center for Tropical Agriculture in Nairobi, Kenya. We have Dr. Lynne Carpenter-Boggs from Washington State University in Pullman, Washington, and then Dr. Andrew Margenot from the University of Illinois at Urbana-Champaign. So just to give you a little bit of background on all the speakers, Dr. Kihara is an agronomist at CIAT in Nairobi, and he specializes in the development of decision support tools for site-specific nutrient management recommendations in sub-Saharan Africa. Dr. Carpenter-Boggs is a professor and research scientist at Washington State University, and her research focuses primarily on biologically improving crop and soil health, and also the sustainable use of agricultural byproducts. And then lastly, Dr. Margenot is an assistant professor at the University of Illinois, and he addresses the foundation of all cropping systems, which are soils. He's looking at how we monitor and manage soils as natural capital, and he looks at how human activities can either enhance or compromise soil services to human societies, with an emphasis on food security from both urban and rural agroecosystems in the US Midwest and East Africa. And of course, all of our speakers are welcome to introduce themselves a bit more, and then they'll be talking with you about their research. For those of you that aren't familiar with AIARD, AIARD is short for the Association for International Agriculture and Rural Development, and it is an association of both professionals and practitioners in international development. They have experience with an intellectual and institutional capabilities to articulate and address broad-based as well as more focused development issues in agriculture and rural development. And AIARD's mission is to improve the quality of life for all people by improving and developing global capacities to respond to new challenges and opportunities in helping to eliminate poverty, improve food security, and conserve and protect the environment in order to stimulate broad-based economic growth and sustainable development. And I'll be sharing a few links in the chat here if you'd like to learn more about AIARD if you're not very familiar with them. And so this FLF Fireside Chat series is specifically focused on the Future Leaders Forum Fellowship Program, FLF, and the objectives of this fellowship program are to facilitate student attendance and participation in AIARD's annual conference, help broaden student vision to build a broad array of social, cultural, economic, and scientific skills required to become an effective 21st century professional in international agriculture and rural development. And then there's also a really nice networking component within the FLF program, which allows students to meet with influential individuals, both from the research sector, non-governmental organizations, from the policy sector, etc. So we've got our Future Leaders Fellowship program will be held online this year. Applications have just opened up, and I will be sharing the link for that as well if you have, if you're either a graduate student or have graduate students that might be interested in participating. And then last, before we get started with Job's presentation, we have AIARD's annual conference coming up June 7th through the 10th. It will be 100% virtual. There are some member-only presentations, but the majority of the conference is open to the public. I'll post the link to register for the event in the chat. And if you have any questions, you're welcome to contact Ariel Rivers, who is on this call, and her contact information is there as well. And that will also be posted in the chat. Okay, so with that, we're going to go ahead and I will let Job share his screen and he can go ahead and get started.
Yeah, hi everyone. This is Job Kihara. Let me first of all do my screen sharing. Share this. I hope my screen can now be seen.
Yep, we can see it.
Yes.
Okay, great. Just a minute. So that I share also my video. Yeah, great. Yeah, my name is Job Kihara. I am an agronomist, as Lee has introduced, and I work with the Alliance of Biodiversity International and CIAT. I'm based in Nairobi, Kenya. As this is more of a career sort of a team, I would also want to mention that I started my career with the support of IFS those days. I think it was called International Foundation for Science, who supported me to do some little research before I went for my PhD, where I studied soil aspects in University of Bonn in Germany. Now, today I want to talk about soil health management in sub-Saharan Africa, provide some highlights and some of my personal perspectives on this. I am a team leader within the organization that I'm working with, and I lead work on soil and water management. I need to show this up. Yeah. I want to start by giving a brief introduction of the farming context for sub-Saharan Africa, where I mostly work. I will also talk about the plot level work that I'm involved with and provide some landscape approach perspectives based on my experiences and work. Here is just to appreciate that sub-Saharan Africa provides us with the greatest potential for increasing productivity due to the high yield gap between the potential and the actual yields observed in farmer fields. This graph shows a maize production, but the trend is the same for other cereals, legumes, and also tuber crops. The production is mostly under smallholder farms, which are in diverse environments, both in terms of socioeconomic characteristics, but also in the biophysical issues. There is low application of external inputs in these production systems, despite that some of them have undergone degradation over the years. Most of the production is also under crop livestock mixed farming. So there is interaction between livestock and crops. And usually production is for household food security as a key goal. Now, this is to show you some of the plot level work that we are involved with and using this to assess various aspects of soil health. This is a long-term experiment on conservation agriculture that I have been running with my team. And this is assessing the role of minimum tillage, role of rotations with soybean, intercropping, which is a common practice in this environment. And the key highlights from these long-term trials started since 2003 and still ongoing is that minimum tillage with residues after a few years, 3 years or so, achieves the same yields as the conventional tillage systems. We also see that when cereals are rotated with soybean, there is no need to apply nitrogen as an external input in those systems because of the biological nitrogen fixation that is realized with the soybean. The other information we have obtained is that intercropping maize and soybean, or even with other crops, results in high land equivalent ratios, which is a measure of the overall productivity of the system when there are multiple crops compared to monocropping systems. And we have also seen when we assess the life in the soil, that is the microbial biomasses and activities, we also see that the intercropping system, because of having multiple crops at the same time, has quite a diverse array of microorganisms and activity compared to the other systems. The second plot level work that we are doing is conducting and maintaining a long-term trial on integrated soil fertility management. This trial involves a use of tephrosia rotated with maize. It also involves intercropping of maize and soybean under conventional systems and application of manure. By integrated soil fertility management, it mostly refers to the application of combined organic resources and fertilizer resources. What we have seen as the key highlights from these long-term trials is that, again, when we do rotations with tephrosia, even without applying other fertilizers, we achieve the same yields as the systems that have full fertilization regime. We also have seen that application of manure not only improves productivity, but is improving also the life in the soil, shifting the microbial populations to the desirable side. All these trials with 17 years of management involve fertilizer N and P variations, so they can help us to understand the combinations with organics. This is just to show you, when we are talking about soil health, really, we want to understand also the life in the soil with combinations to the fertilizers, nutrients. You know, we want to use microbes, which are a good signature of soil health. And in this case, we have compared with undisturbed fields as a benchmark. And we do see that the microbial populations there are quite shifted, as you can see in the graph. And the green and the blue sort of dots, in that case, involve use of organic resources, farmyard manure, and agroforestry practices. And again, you can see those populations are shifted further away from those ones that receive only fertilizers. Those are the red dots. So we are using this to try to understand how soil health is being influenced by management practices. And we are also doing another array of soil microbial studies, including using specific genes, assessing those, and assessing also the activities of different solubilizers. So this is just a teaser of what we are doing in our soil health assessments. Here it is to also indicate the microbial activity in terms of soil respiration, looking at CO2. And this is based on conventional CO2 measurements in the fields. And if you see the fluxes of CO2, is that the systems that have been applied with farmyard manure have increased fluxes compared to the systems that do not have manure applied, regardless of the fertilizer rates that have been used. This again indicates for us that there is higher activity of microbes in those systems that have been managed with manure application. Now, I would want to go to the third aspect that I want to talk about to introduce the landscape perspectives. Farmers produce under very complex environments of the landscape, and this results in very varied responses and variations in organic matter in the systems. There is also transfers of organic resources from the farms to other farms or even to other households. What happens to those transfers of resources and the fields that these are taken from? We try to compare under that kind of context when we apply the blanket fertilizer system compared to site-specific using a specific farm level soil test. It's called a soil dock test kit. And we did some trials in Tanzania and in Zambia, several farms, and we used the soil dock kit to inform us on what particular nutrients should actually be left out, omitted from the local recommendation. And we did these omissions and found that the results, the yields with the local recommendation and the soil dock recommendation where some nutrient was omitted were basically the same, which means that this type of tools can be used to inform site-specific recommendations. The other strategy we have used is indirect indicators or proxies of soil carbon. And these are using landscape positions, but also looking at the history of field management, that is the frequency of manure application, but also the proximity of a specific field to the homestead where the farmer resides. And what we have seen is that, yes, the slope has a great effect, with those fields that are on flat or very gentle land having higher yields than those that are on the slopes. And yield in this case is a productivity, is a benefit, an ecosystem service of soil health. We also have seen that the distance from the homestead matters, with those fields that are very close to the homestead benefiting from organic resources, kitchen wastes, having higher productivity than those that are further away. Then the frequency of application of organic resources, fields that are applied more frequently with organic resources actually have higher productivity than those fields where manure is applied once, for example, in every 5 seasons. So under this type of fields, when fertilizers are applied, the kind of responses we obtain are very, very varied, with some fields actually not responding at all and some fields responding quite very highly. So these are because of the high variability of those fields and the context that we have already talked about. The photo that I'm showing here is a field that we encountered in a place in Tanzania, where the land has recently been converted from forest land. So very fertile, no need of application of fertilizers, but it's usually under the general blanket recommendations for fertilizers. What we have seen when we try to cluster the type of responses obtained from such landscapes, we have come up with 5 type of clusters. And these are based on more than 250 fields scattered across 5 different countries where omission trials were conducted. And we see that some fields respond well to fertilizers, but some fields actually do not respond to fertilizers. And you can see the percentage occurrences of such fields in sub-Saharan Africa. And we try to understand what are driving a field being located in one cluster and not in another cluster of response pattern. And we found that calcium and magnesium are important, as well as phosphorus, but an array also of micronutrients, that is zinc, boron, manganese, and aluminium. And what we did in a subsequent study was to try to understand the role of these micronutrients in improving productivity. So we did a meta-analysis across studies in sub-Saharan Africa, and we observed that the yield gain because of application of secondary micronutrients is 25% over the yields that are obtained with the NPK fertilizers. In this environment in sub-Saharan Africa, most of the fertilizer applications, especially for cereals and legumes, has been N, P, and K, neglecting the important micronutrients. The photo you see here shows a crop that we applied with sulfur and zinc in addition to macronutrients. And in the foreground, you can see the crop that was not applied with the micronutrients. So we see some good change because of application of micronutrients. And when we assess this in terms of returns, dollar returns, because the application of micronutrients is very small, we actually observed quite some good income that farmers would gain by adopting application of micronutrients. The other research that we are doing with the team is to try to improve the cropping configurations, considering not only the productivity, but also the benefits to the soil. And what we are seeing here in the first photo that has somebody standing there is a system we call mbiri mbiri, for Swahili word for 2 and 2. 2 rows of maize and 2 different legumes in the larger space between the 2 maize plants. And the different crops have very different growth patterns. So they minimize competitions. Each crop maximizes on its productivity, which is something that we are now testing to try to improve the cropping systems here. The other work that we are doing, which is ongoing, is to try to adopt relay cropping of cover crops within the systems. And in this case, we have cowpea in the next photo that you see there, planted in a crop of maize. And these are ongoing. We are getting some preliminary results and quite interesting ways of managing the systems. I want to provide some reflections from what I have said so far. And I want to say that understanding the context and drivers of responses is important for us to manage soil health in the region. It's important for us to develop strategies that will support local recommendations. I've talked of landscape variables that we are using and developing site-specific sort of manuals that can be used by extension, but also to employ tools such as the soil doc test kit, in-field testing that can improve on site-specific management so that we can improve on how we manage our soils. I'm also saying as a reflection that management of micronutrients and integration of those as part of the fertilizer strategy is important, whether we use organic resources for this or we use external inputs, industrial fertilizers. It is important for us to do this to improve the systems. And it's important also for us to increase our understanding of the environmental costs associated with the different practices that we are working with. So this is an area that has not been well studied in Sub-Saharan Africa, and is an area that I and my team are very interested to continue doing and investing a little bit more research. I also put in this publication here titled Soil Health and Ecosystem Services. We did this as a summary of the experiences and lessons, data available for Sub-Saharan Africa. We published it in 2020, and I think it would be a nice resource to refer to in the context of soil health. I think these are the minutes that I had to spend with you. Thank you very much, everyone, for listening.
Great, thanks so much, Dr. Kihara. We appreciate it. If you have any questions for Dr. Kihara, feel free to post them in the chat, and then we'll get to everyone's questions at the end of the webinar. So yes. With that, thanks again, Dr. Kihara, and Dr. Carpenter-Boggs, you're up.
Thank you very much.
All right, good morning and or good evening and or good afternoon, depending on where everyone is. Hi, I'm Lynne Carpenter-Boggs. I'm really happy to be here with you today. And I will share my screen. And start at the beginning. All right, so I'm happy to be here with you today. I'm primarily going to talk about some experience I had in 2018 in Malawi. I was fortunate to spend 5 months there and learn about issues and management decisions that are being made to improve productivity and soil health. And yeah, especially since we have graduate students and young scientists online today, I really hope that you will look into the Fulbright programs. Wonderful opportunities there for research fellowships, and I'm very fortunate to have gained experience from several different funding sources. And I know that Rita Abiganim is online today and invited me to give this talk. Rita is one of the reasons that I have really gotten further into international research, and was fortunate to go to Iraq and Jordan because of work with Rita. And since then, and somewhat before, have also done work in Bangladesh, Kazakhstan, Kyrgyzstan, and several African countries. And I wanted to mention that soil health is a really wonderful sort of development in itself, that we are now talking about soil health as a very universal and holistic way of understanding what soil is, the characteristics that it needs to have, and what it does for humans and for ecosystem services. So in a way, soil health is universal, but still the issues that are faced and the management that are going to be right to really improve soil health are local. So this is a shot of the landscape in central Malawi, primarily plains or rolling hills, and highly seasonal rainfall. So one of the issues that we find here is, of course, drought periods. But also there are low-lying areas. And as has been mentioned, one of the issues really across the world is productivity. So levels of productivity, how we can support soil health to support high productivity overall and during challenging periods. And when you step into a new place that you are not familiar with, I think it's really important to understand much more of the food system, not just the soil and not just one aspect of the soil that you want to study, but what are people eating? You know, if you can try to introduce new foods or even new varieties of foods, but if they don't fit with what people are used to eating or what they want to eat, it's not going to work. So I really promote the idea of eating local when you get somewhere. Understand how foods are being marketed, as well as how people are managing the soil. What is the whole agricultural system that people are really functioning in? So I was very fortunate to observe and do some research on the Heifer International project in central Malawi. And it was one of the things that impressed me about it was the overall structure. It was very efficient. So the whole country is split up into agricultural regions, or EPAs. And this project had one salaried EPA officer in several EPAs. But through that one person, they covered an entire EPA. So that one officer was able to train and work with 200 to 300 lead farmers. And those people were incentivized by getting good training. They were actually had professional training on multiple sustainable ag methods. They were given a bicycle so that they could interact with the other farmers they would be working with. They were supplied with poultry to diversify their operations. And if they used the methods that they were trained in, they could increase their yield. But those lead farmers then had to, were required to interact with more farmers. They had to lead them and train them. So each one had 20 to 35 following farmers. So again, from one salaried person, this project per EPA, they were able to engage 22,000 farmers. And so that was one thing that just really impressed me. This project gave people options also. So again, soil health is really local, and what's going to work the best is going to be local decision making. So each of the lead farmers was given thorough training in 8 different methods, from zero till to using planting pits, or also called in some areas zai pits, using agroforestry, mulching, intercropping, crop rotation, making compost, or making bokash. And I'll describe bokash later if you're not familiar with it. So all of these methods have been researched, and all of these can improve soil health. The question is, what was going to work for these producers in the project? So, you know, one of the things that is promoted really worldwide is mulching, covering the soil surface to reduce erosion and reduce evaporation. No-till is also a very wise practice in many areas, but not everywhere is that going to be the best decision. And this picture does relate to that. So in some areas, the soil condition just simply isn't optimum for no-till. So without tillage, the rooting of plants can be limited, especially in high clay soils or compacted soils. In some areas, the soil moisture is too high, and lack of tillage can further exacerbate overly wet soils, and you can end up with root rots and actually lower yields. And this picture relates to the issues of residues for mulching. So there are many reasons why crop residues may not be available after harvest. They might be used for cooking fuel. In Malawi, what happened was that crop residues were burned in order to harvest mice. So as the maize was harvested and crop residues were then on the ground or piled up, all of the mice would run into the residue piles. But mice are apparently delicious. I didn't have the have the wherewithal to try, but were very popular in May. So people would burn these residue piles to chase the mice out and harvest them. There are many other reasons that people burn the maize piles, and sometimes just kids like to see something burn. So trying to promote use of mulch was really a non-starter in this area. It was too hard to come by mulch reliably. So again, when farmers have choices among many methods that can all promote soil health, which are the ones that they're really going to choose? So that's what was fascinating in this project was the majority chose to use planting pits, which I'll describe more, intercropping together with planting pits, and compost. So a planting pit, again, in some areas called a Zai pit, it's really hard to take a picture of a planting pit because it's a slight indentation in the soil. But on the left, this is basically what it looks like. It's just a low area.
Oh, I think
Did we lose somebody, Nikki?
yeah, I think Dr. Carpenter-Boggs, maybe her internet kicked her off. Yeah, I'm not quite sure what went on, but so it looks like she has gotten kicked off. Andrew, would you like to hop on? And then maybe we can just have Dr. Carpenter-Boggs finish later, or she can finish the rest in her panel discussion.
Sounds good.
Andrew, would that work for you?
That works for me, yep.
Okay, awesome. I appreciate your flexibility. Are you able to share your screen? Does it show up on your end?
Let me give it a shot.
Okay.
Let's see.
You should be co-host, so I think you'll have.
There we go.
Awesome.
Sorry, can you hear me?
Oh, yeah. All right. We were going to have Dr. Margenot hop on, but if you can jump back on.
Sorry about that. Yeah.
Right. Okay. Are you, I think I need to make you co-host again. There we go. All right. Thanks, everyone.
Okay, so the planting pits just look like a slight indentation in the soil, and the crops are planted there versus what's common in the area is ridge planting. So to understand these choices, we interviewed a lot of farmers, And this was one of my favorite quotes. "I saw these farmers digging all these holes and I thought they were crazy. Then I watched them harvest so much more and I became a lead farmer too." This was from Elodie Flywell, who started using the planting pits. The planting pits are a lot of work. And so it was very daunting for people to think about taking it on. But this is basically how they work. So the ones they were using were about 20 centimeters or 8 inches in depth, about 1 foot or 30 centimeters in diameter. So they would dig out the holes, separating the topsoil from the lower portion of the soil, put the topsoil back in at the base of the hole, along with 2 handfuls of compost and a little bit of mineral fertilizer. Then they may add additional bokash and then put the lower soil back on top. So they were putting the richer soil in the lower portion of the hole, so that that's where the roots of the crop would have better access to them, especially during the hot, dry period. Then they would intercrop 4 maize seeds and 1 legume seed in each hole, each pit. And then where it was possible, where they had mulch, they would apply that. The second and third year, they would partially dig out that pit, add some more compost and a small amount of fertilizer, and do the same maize legume intercrop. Sometimes they would go into a crop rotation with a different crop. And then the 4th year was usually when they would redig it entirely, or they would go to a different crop. So something like cassava, groundnut, soybean, or tobacco. And these pit systems have been studied in other areas. They work very well in places where it's important to capture rainfall when it happens, because in the traditional ridge system, it can actually exacerbate runoff of water. So the low areas in the field between the crop rows, they tend to have very low infiltration. So when precipitation hits that interrow, the water can more easily run off of the field, and sometimes carrying, of course, topsoil and nutrients with it. Whereas in the pit system, there's a slight indentation in that pit, and so runoff even from outside of the crop planting area then tends to flow into the pit, and we have high water infiltration into that pit. So some barriers we saw is that it is a lot of work to dig these out. One of the ways that these communities dealt with that is just to help each other get that first 1/4 acre dug. So many hands make light work. People working together got it done. Making compost or bokash was difficult for some people because it was a very new process. And it's seen as inappropriate for some crops, especially the root crops that need to be dug out. It's just harder in a pit than it is when the plant is in a ridge. But there are definitely advantages. People are seeing pretty dramatic yield increases in this region, up to multiple times their prior yield, and seeing they're able to plant earlier and have improved drought tolerance. We did some analyses of soils in the ridge and pit system. The soil pH was improving even after just a couple of years. We could show faster water infiltration and increased water holding capacity. Also, of course, the compost and bokash was adding micronutrients and a wider range of nutrients than just the mineral fertilizers that were available. And in years 2 and 3, after that initial dig out, it was actually less work than using the ridges. So in addition to having adopted widely this new way of planting, there was really an evolving understanding of what conservation agriculture means in that area. So of course there's there's an official definition from the FAO of what conservation agriculture is. But through seeing what was really working and what was conserving soil and building soil in this area, their new definition of conservation agriculture was becoming the planting pit plus an intercrop, because that was what was improving soil health and yield much faster. I'll just mention that an additional project that I'm working with now is a Farmwilla decision tool that allows farmers to track changes in their soil, track their own activities, and to share that information within their community. Thank you very much. Very sorry for that break in my presentation.
Great, thanks so much, Dr. Carpenter-Boggs. That was wonderful. And again, if there are any questions, feel free to just type them in the chat, and then we'll go ahead and turn it over to Dr. Margenot.
Okay, well, Nikki, thanks for having me. I'm glad to be here. And I recognize, well, Jove, it's good to see you again. And then I recognize a few of the audience members. It's a small world, I think. So my name's Andrew. I'm an assistant professor at the U of I. And I want to give you a brief overview of what I've been doing before I arrived here almost 4 years ago, and what my group is doing on international agriculture with respect to soils. So in brief, I know that we have a panel in a few minutes, so to keep this really quick, I'm going to talk about an example of how weathered soils, which are more predominant in the tropics, might carry unique considerations. And this is, I think, true not just for soil health, but also for things like agronomy 101. And I think Dr. Kihara spoke pretty well about this. The other major theme is that we're doing some work on high value perennial crops, cacao, and also coffee. And so just to give you a flavor for what we're working on, there's a whole lot of unknowns, I think, in these tree crops when it comes to what constitutes soil health. All right. So Nikki, I'm not sure how much time you want me to reserve. If we have a hard stop at 12, I can go until 10 of, or
10 of would be great. Yeah.
Okay, sure. Alrighty, so a bit about my own background. A lot of what you're going to hear was set in motion when I was still at UC Davis in the graduate program there. And then in 2017 came to the U of I into crop sciences. So there's more details about these projects that are on our website. That's the link down there. This is in Guatemala with coffee in the background. Really sandy soils, definitely not volcanic soils. That's one of the things that I want to talk about today. I think we have a lot of stereotypes on soils in the tropics in general, and that can stunt and maybe mislead research efforts. So a quote from the first soil survey of the US when they were mapping soils, that did begin in our state of Illinois. The director of that soil survey made this comment about 100 years ago. I like it because it gets at the idea, well, not just of job security for soil scientists, but that there's always going to be something else. 100 years ago, it was mapping soil types. We kind of know what soil types we sit on, at least in the continental US. When it comes to other parts of the world, or even in modern day, there's new questions about soils, and arguably soil health is one of those, whether you're in the US or in a different part of the world. So this photo that was taken by a farmer in Western Kenya, in Siaya County, I think captures what we try to do pretty well. We've got long-term no-till on the left and long-term conventional till, all by the hand hoe, on the right-hand side. And what interests me is the mechanisms that explain why we intuit that the left-hand soil is better somehow, right? Health is a very amorphous concept. What does that mean? How does that work? And note the reddish tone to both of these soils. So there's obviously a darkening due to organic matter. What I want to point out is that there's a lot of edaphic contexts, not just climatic, but edaphic. So soil type, the mineralogy. If you're in a place like in Western Kenya, highly weathered soils are just different. And so we have to rethink a lot of what are mostly temperate-based indicators of soil health. Soil health came from Cornell. There are sandy soils in the northeast of the US. They don't even apply that well to the Midwest, let alone perhaps a tropical climate with weathered soils. Or maybe they do, but perhaps we should be careful with those assumptions to make sure that we get things right. So in the interest of time, I'll just skip through these. I think you got a flavor of the main question is that in the tropics, we have weathered soils. And so a lot of what our group does is in the tropical belt with lots of different organizations. And I'm happy to say that CIAT with Job was the first encounter that I had with international work. The reason why the tropics interest me is because of weathered soils. And here's a good example from Western Kenya yet again. But I want to point out that we shouldn't fall into this this fallacy of thinking that all tropical soils are weathered. And you'll hear that term tropical soils. It is totally unscientific. It's not a correct term. And it, I think, is getting at that you've got more weathered soils like oxasols and ultrasols in the tropical belt. And if we define that as a climatic region, this makes sense. But this is important because in the tropics, we have as much soil diversity, if not more, than in the temperate zones. So it's not fair to pigeonhole, I think, soils in a tropical location as being highly weathered. There's some phenomenal soils in places like in East Africa. You also can get very different soils if you go up the mountain. And that's the second theme of what I'll be talking about is coffee production. So on those landscapes, they're definitely not weathered soils all the time. So key point here is that I think we should be more careful as we begin to apply soil health concepts in the tropics to not carry the baggage and this mythos of weathered soils. So with that, let me just skip to the next theme so we can have some time for the panel discussion. This is the second thing that I like to work on. I love coffee, and this is kind of a pet interest meets soil science. So my group is working at these sites in, I would say, Central America or Latin America, but we do have a site in SoCal near San Diego. But largely our efforts are working in Central America. A lot of this is just very basic, doing soil profile pits. This is in El Salvador to try to understand the soil frame, the soil context in which to frame a soil health assessment. And one specific question that is relevant to this, to this gathering today would be, there's a maybe nice conceptual and metaphorical link between quality of soils, i.e. health, and the quality of the coffee, more of the cup. And so one open question is, well, to what extent is this metaphor actual? Just like soil health, does it translate to human health? Great metaphor, might be more complicated and indirect. So in these three subsites, we're doing work where we're going all the way from soil health assessments all the way up to doing cupping scores. If you don't know what a cupping score is, I see a couple of experts on coffee here, but I'll tell you real quick. It is a way that you use a sensory evaluation, more or less, to score the quality of the final beverage. So this integrates from soil all the way up to the final product. High quality coffee can fetch a higher price. So for a lot of specialty coffee markets, smallholders can make a fairly decent living. So we're working on Arabica in 2 sites in Central America and Robusta in Ecuador. And I realize that Robusta is often dismissed as the not good coffee, but there's increasing interest in forest grown specialty Robusta. So that's what we're doing there. And we're in the beginning of these projects, trying to link soil health indicators, which also means sometimes changing what we think of as a good indicator in Illinois, that may not be as useful in, say, Guatemala. So that was a lot, but I hope that was useful. I will end on this slide giving you a flavor for, this is on a single mountain in El Salvador, on one volcano, the different soil types we found, just to show that in very small spatial distances, that was redundant. In small distances, there can be tremendous edaphic variability. And as a few speakers have mentioned, I think harnessing and capturing that diversity is really important for accurate soil health assessments. Okay, that's all I got, Nikki.
Great, thank you so much. I really appreciate it. Okay, so now we're gonna jump to the panel discussion. I see We had a question earlier from Dr. Kihara's presentation, and it might actually be applicable to everybody's presentation. So the question was from Gary Alex, and it's what level of response, low, medium, or high, was adequate to be financially viable? So maybe this is kind of a general question about, you know, what are the trade-offs between soil health and financial viability?
Yeah, thanks, Nicole. I think I can give response to this question. The kind of response patterns that we have observed, some of them, as I mentioned, are constrained because some missing nutrients have not been incorporated in the regime of fertilizer application. When these are applied, some of those fields that are low response may turn already into high response and also be profitable. But in the context for the data that I showed, only the ones that have moderate response and the high response would be profitable. But not saying that the others are not profitable, they would be profitable if the right missing pieces are taken care of. And maybe just to mention, some of those missing pieces may be managing the acidity of the soil, you know, that unlocks the productivity. It could be addressing organic matter, which may be too low in those soils. Again, addressing that may also increase the responses and then make those profitable. Yeah.
Great, thanks so much. Lynn or Andrew, do you have any additional comments maybe on financial viability and soil management?
One thought is that I know in the Midwest, our soils were too good for soil health practices to really pay for themselves. It's a good problem to have, but we have such high organic matter contents, cover cropping barely moves the needle on carbon content. And there's really a disincentive to practice things that will foment soil health if you have a great starting point. So I think for some degraded soils, the ROI on soil health practices might be a lot bigger and they'll likely taper off as soil quality gets better.
Great, thanks, Andrew. So we've got a question for Lynn. What is bokash and how is it different from compost?
Yeah, I see that was one of the slides I removed in the interest of time, but yeah, bokash is similar to composting in that it's a way to utilize waste organic materials. So you do a similar process of just mixing different materials to provide sufficient carbon, nitrogen. It's though a cool and more anaerobic process. So often a microbial inoculant is added. It can be just baking yeast or some things like effective microorganisms, EM, have been used for bokash, but really just anything to sort of get that fermentation jump started. So it's more of a pickling process than a real thermophilic degradation like composting is. But it does, you know, again, a similar process of stabilizing the nutrients in that organic material so it can be then more easily applied to the field.
Very cool, thanks, Lynn. Feel free to add more questions in the chat if you'd like. One question I have for all three of you is, you know, outside of domain knowledge, of course, are there any specific skills or areas of expertise that you have found perhaps surprisingly helpful in your area of research? So like something not directly related to soil science that's really come in handy, or that you would recommend that students develop or young career people develop?
Listening. Listening, broad observation, note-taking, because you forget a lot of things. But yeah, I do feel like we should do a better job at sort of mixed methods, giving people some background in how to take social data and what a good question looks like.
Yeah. When I started my career as a young scientist, I think there was a lot of efforts to develop what were called T-shaped skills. And those are the social skills that I think Lynne has mentioned. For some time, I think this has been a gap, and this needs to come back strong. And the other area that I have seen nowadays in our work in trying to develop recommendations that farmers can use, this has to be contextualized into farmer typologies, you know, and that area is not a soils perspective or agronomic, you know, strength, but it is an area that needs to be strengthened for these practices to be contextualized. So those socio-economics aspects for people to be able to communicate with people in other disciplines, I think is very important.
I would probably say two things, and I'm still starting off here. One is statistics, sorry, but especially for descriptive work, or if you're trying to figure out what is going on and you're trying to describe the site, get to know these different landscapes, multivariate stats are really useful. That's a concrete one. A more amorphous or soft skill would be patience. A lot of times things move more slowly, and patience at different scales, I guess, with some field sites perhaps, but also being able to go back to the same field site to build relationships and trust with producers, I think is really important.
Great, thanks everyone.
I'll also add in different languages. Yeah, I wish I knew French and Spanish.
Great, thanks. Lynne, I've got another question for you, so don't mute yourself. The question is, and this is actually related to what you're talking about with kind of the mixed methods. Was your work also connected to market demand for the increased production and selection of what was intercropped or rotated? We'll start with that one, and there's a few other questions. We'll start with that one.
So that project, I wasn't getting into that that aspect of it. I was only there for a few months, but that's absolutely a critical part of it, right? That the crops need to not only benefit each other biologically, but they need to be what people want to eat and sell.
Okay, so another question on a similar topic was, are there mechanization options for the Xi pit work?
Yeah, definitely. That can be done with augers. You know, if that, so yeah, basically any tractor with a like a PTO can do that with an auger. You know, if there's money available in that community, or you know, through a grant to do that.
Okay, and then lastly, were there gender implications to the pit work? So was there more labor for women versus men?
Actually, so in all of the areas that I've worked in Africa, women are the majority farmers, and the most willing to take on new methods, the most willing to learn new things. So yeah, in that project, there were a majority of the lead farmers and follower farmers were women. And I didn't actually look at whether there was a gender difference in how much they adopted the pits, but the pits were adopted by the vast majority of everybody. So.
Great. All right, well, thank you again to Job and Lynne and Andrew for your wonderful presentations and panel discussions. I did record this webinar series, so we'll be posting it to AIARD's website. And if you have any additional questions or anything, you're welcome to reach out to me. I'll post my email in the chat. But thank you again for taking the time to share your experience. Really appreciate it.
Thank you.
All right.
Thank you.
Thanks, everyone.
And
Take
great
care.
to meet you,
Bye.
Andrew and Job also.
Thanks. Bye.
You too.
Great meeting you, Andrew.